Hi, hi. This is Gunasegaran, Assistant Professor for Mechanical Engineering at SNS Institution. Now we are seeing about reactive components in cyber physical system. Okay, first we are seeing about introduction. This presentation introduces reactive components within a CPS. CPS means cyber physical systems. Okay, CPS integrates computation, communications and physical process into a framework. Reactive components are essential because they continuously respond to input from their environment, making real-time decisions that affect physical systems. The sessions also cover the main properties of these components such as determination, composability, consistency and reactivity. Okay. Additionally, we will study how these components are composed to form larger, more reliable system and how different design approaches such as synchronous and asynchronous models are used to implement them. Applications in various industries will also discuss it. Okay. Then reactive components, it is a constantly responds to input from the environment, producing outputs or action accordingly. For example, a temporary sensors reacts to changes in heat while an actuator moves a robotic arm when commanded. Okay. Control units in cars such as a braking systems are reactive because they must respond immediately to driver actions. Unlike passive components, reactive ones are event driven and time sensitive. Then they operate in loops of sensing, processing and acting. Their ability to continuously engage within real-time signals make them indispensable in CPS for automation, safety and decision making in dynamics environment. Okay. Then properties of reactive components. Reactive components specific properties that makes them reliable in complex systems. Determinations ensure the same input always producing the same output, reducing unpredictability. Okay. Composability allows these components to be combined to create larger complex system concurrency, support multiple operations happening to once without conflicts. Okay. Reactivity means the system responds within a bounded time, crucial for safety, critical applications like airbags or medical devices. Finally, safety and liveness guarantees correct operation and continuous service. Okay. Then composing components. Complex CPS are not built from the scratch but rather than the composing smaller reactive components. Composition means combing models into a single system that performs multiple functions. For example, say an autonomous car, sensor, GPS models, then braking system and controls are the composites into one unit. Okay. Then design of reactive components. Reactive components can be designed in different ways depending on system requirements. In synchronous, all components update in time steps suitable for circuits and real-time embedded system where predictably in critical. Okay. To ensure smooth functioning, coordination, protocol and implementation to handle communication and error recovery. Okay. Each design has advantage. Synchronous system provide predictability while system support scalability and flexibility. Then examples in CPS. Reactive components are widely used for cyber physical system across industries. In automotive system, ABS braking continuously react to wheel slipping conditions, while control adjusts speed based on the sensor input. In smart grid, reactive components balancing the electrical loads in real time, improving the efficiency, preventing blackouts. Then industrial automation having a relies on programmable logic, PLC, programmable logic units, logic controls, the reactive sensor data, activating motor, valves and alarms. Okay. Then conclusion, reactive components are the backbone of the CPS. Their properties, determination, concurrency, complexity and reactivity make them depends building blocks and modern applications. Okay, CPS would fail to the function effectively. In summer, understanding the roles, properties and design essential for creative, reliable, safe and innovating systems. Okay, thank you.